What you doing, Rick?
Trying my best to cut some foam core. Get ready for laying out these horizontal stabilizer skins.
Cool.
Not terribly exciting work.
It is not. It is tedious. Yeah,
That's kind of fun though.
Yeah, this whole composites thing. The thing I find, I think, the most fascinating about it is, it's just the most basic of hand skills, you know. And it creates an amazing thing. But it's just we're going to cut some foam, and then we're going to take that foam and we will bevel the foam, and then we will laminate the foam. So up in here, this is a couple of weeks worth of part-time labor. There's 2 kits worth of airplane parts there. I've been working over here on this table. Cutting all of the carbon kits. And this is the amount of scrap we have. We're doing pretty good scrap-wise. We have all the fun.
Well, with exception of a couple of mistakes.
Yeah, we're doing
all right.
Yeah, we're doing all right. It's coming back. It's coming back. But it's tedious, boy. This part is prep, and then the part has to come quickly because, well, the resin's going off. Yeah, so we have to have our shit together by the time we light the resin off. So the part comes relatively quickly. But these molds are designed to be pulled several times. For instance, over there's the horizontal stabilizer molds. There's a top and a bottom. They are bilaterally symmetrical. So there is no right and left part on the airplane. So we're going to cycle those 4 times.
It's a very cool feature, by the way.
You know, I'm a lazy man, Rick. I'm a lazy man. And then there's other parts here where one mold, 4 parts. So this one here, we're going to rebuild these. These are this part. We're rejecting these parts and we're going to rebuild them because there's this tooling error. I went through that on the last one. But that's one mold, and we'll pull it 4 times per ship set, per flight set. So yeah, kind of boring, but also really important.
Oh yeah.
Yeah.
Very, very important.
Yeah. And the better we are at this, and the more of this we do, the better position we're going to be when we pull out the resin and start doing that. Because we don't have a lot of room, we're going to just break it down process by process. So we'll do all of these, make as many of them as we need, set these molds aside, set the parts aside, go grab more molds, and keep doing that till we're done. And the last ones will be the big ones. Because all of this needs to be bonded into the big ones.
Small to big.
Small to big.
Way to go.
Yep. All right. Thanks, Rick.
That's it for now. Back soon.
Bye. All right. So I'm prepping a bunch of 3K. This is a 3K 2x212. This is a Hexcel AS4 fabric, which is pretty much all I'm going to use in terms of a bidirectional cloth. Up here, this is my uni, and this is a what is it? Okay, this is a Zoltec PX35 fiber. It's about a 9-ounce aerial weight cloth, and this is what I'm going to use for the uni. So I am now prepping for the horizontal wing, or the horizontal stabilizer spar. All right, so I have over here, It's going to go into this mold. And it's going to fold up in there, and I'm doing 2 plies of bid plus minus 45, and then 6 unis. And then they overlap on the bottom and on the top to create a hard point. All of this is prepped. All of this is prepped for 2 ship sets. And Rick has been working on these. These are the foam prep for the horizontal stabilizer skins. And there's a really deep taper here at the trailing edge, and then everything else is tapered 45 degrees. And this is the instrument pod. It is currently covered in wax. And we're going to lay up flanges on all of these. All of these areas are going to get flanged. And there's going to be core that goes here and here. Lower pod, it has been prepped as well. Same deal. 1 core 1 plus some tapes around the edges. And the bottoms will be 6 plies in the back because our electrical connections, the 38999s are going to interface here at the bottom of that pod. Still have to prep this, and all of this is done up to 2 ship sets, and I'll be getting more into that when we start laying up, which should be this week. On the list of cool shit, this is the finished full 3D print of the intake manifold. It's beautiful. And that is nylon 12. That turned out beautifully. Anyway, I'll get back to this part right now. We're going to lay some stuff up. So, promises to keep, miles to go before I sleep. See you later. All right, let the laminating begin. So, this is the center bulkhead for the fan. It is 10 plies overall up the flanges, and then an extra 10 ply in the middle, making a total build of about 0.160 in the middle. We laid it all up in one shot. This resin is really good about not exotherming. There's resin systems you just wouldn't get away with that. And this is the cheap and cheerful way to do a vacuum bag. Vacuum pump, some Home Depot tubing, a heavy-duty contractor bag, and some bag seal tape, some legit bag seal tape. There's no reason to use fittings or anything like that on a part this big, and these bags hermetically seal on three sides already, so all I got to do is just put it in the turkey bag and seal it up. Now there are a couple tricks. You do want to put some bleeder. You do want to put some bleeder on the back side of that, because you stand the risk of puncturing the bag on the back side of the tool, because it's usually pretty rough. So this has bleeder on the back side, and then has 2 plies of bleeder on the inside. And then you work the bag, you're pushing into the corners, you're working spanners, you know, basic pre-preg lamination technique. These bags are wonderful because they stretch a really long way before they give out. They, however, will not take any sort of heat beyond, you know, let's probably 150 degrees is all they'll take. But this resin system is designed to pre-cure at room temperature, and so this works perfect for small parts. So we have begun making parts. This is just a black contractor's bag. Okay, this is the spar for the horizontal stabilizer mold. All right.
Did you make that mold?
Yeah, yeah,
Why did it have to be sent away? Oh, that was vacuum bag.
yeah,
Okay, yeah.
yeah. So we just I just vacuum bagged it. And this is the bleeder. This is what happens to the bleeder when you turkey bag it. Basically, I've got to take this baby blanket and peel it out. Okay. This all looks pretty good. So this is the perf, and this is the part. That all looks good. That looks like the right resin to fiber ratio. This was not an easy thing to lay up. I laid it up yesterday. It took like an hour longer than I thought. So yeah,
You only have to do it once, right?
I had to do this one
I mean,
2 times per. But yeah,
you're right. But I mean,
yeah. Well, no,
yeah, now you
there's
can pull it.
2 each. So one spar, other spar. So I gotta turn this mold again for 1 ship set, and then we're making the other one for Katie. So we're making 2 ship sets. So I've got to turn this mold 3 more times. Now I will get better at it, and it probably won't take 3 hours that it took me the first time. Okay, but this is always this is what demolding a part looks like. It's always a struggle, especially one as complicated as this. So I'm trying to get this bleeder off of here.
What do you call the bleeder, and why is it a bleeder?
Okay, so what this does is it serves as an air channel. All right, so when you hook it up to the vacuum, it is this which allows the air to move out of the part. And it'll also get permeated with resin. Now this resin is not completely gone off. This should be really hard. All right, it was cold last night, so I'm probably not going to completely demold this part right now, simply because it's still a little bit green.
Could go off. It should go off a little more.
It could change shape.
Yeah.
Yeah, I don't want that. So, but I'm gonna pull the bleeder out. But I'm pretty happy with that. Okay, that's a good sign that I've got the right resin ratio in there, and I'll show you what one looks like that's a failure. So this one is a fail, and the reason it's a fail is that when I put it in the bag, I put it in the bag with something else. This one, and I set the vacuum on a timer, and this one wasn't completely gone off when the vacuum shut down. So what happens is the vacuum compresses the laminate all the way in into the mold. But if you let that pressure back off, it has also sucked the resin out of it into the bleeder. All right. And so this decompresses a little bit, and then you get a dry laminate. This is a dry laminate. This is totally unacceptable. No strength. All right, so that one's trash. but I'll show you. This was one I pulled out of the mold yesterday, and this is a nice part.
So the difference between strong and failures could be temperature and time. Huh?
It's all of those things. Okay, so we've got the resin matrix, and we have the cloth matrix. And the resin changes state. The cloth does not change state. Right? That is not completely gone off. The resin mixes together, and it cross-links with itself, and then it goes through a change of state and becomes a solid. Right? This, and then the fiber, what it does essentially is just keep the fibers in orientation. That's the idea, is that the resin keeps the fibers in orientation, and it adds a certain amount of strength, but most of the strength is coming from the fibers. So this was laid up yesterday. Pretty happy with it. I've got a little bit of business in the corner. It actually stuck into the corner. So I've got to dress that mold out a little bit. But other than that, I've got good registration, and I've got a completely usable part here. So I forget how many laminations. Here, 90, 45, 90, 45, and then these are stepped plies. See how they ramp up? Because this is a hard point. This is to carry the load of the axle that'll go through this, right? So this part sits in. I can probably show you right here. This part will sit right here. Okay. And then this is a primary structural pass-through. Then this part, which is the spar, fits right here. And then that part that was a failure was the tip rib. So this is the root rib, which carries the loads for the hinge. This is an all-flying tail. And then there was another part that was also a failure. That is the rib that goes back here. Okay, so I've got spar, skin, tip rib, root rib, rear root rib, and that one actually goes out to here.
I'd have to throw a drawing in on that.
I will, yeah, I have them over here. Yeah,
I mean, at the time,
yeah. So yeah, so actually it's going quite well. The parts are coming out nicely. I'll grab another one, Dad. So this is the first part we pulled out, and I was a little concerned about the resin not going off, but it was just cold. This is a good useful part now. I had and it had to do with the resin not being completely gone off. I was using a different type of bleeder, a different type of perf. There were two types of perforated material. This acts as a semi-permeable membrane, right? It allows the release of the material so that you don't bond this bleeder in. And that's exactly what happened to this one. This pink stuff, it's called perf. This is just pricked perf. It just has holes pricked in it, like with a needle. And they close up when the vacuum pressure equalizes on both sides. The other type that I used on this that I got a failure off of is called punch perf. It actually has holes punched through it. Used it for years. This is the first time it ever did this to me. But I think it's because this resin was still a little bit tacky. It wasn't quite gone off yet. Anyway, this is the structural bulkhead that goes in here that holds the idler and the main shaft for the fan system. All right, so this is one of the last parts of this, and you can put. There's a couple of different ways that you can do this part of the process. Now, in production, it is perfectly acceptable just to do. What is that? Okay, yeah, nothing. It's perfectly acceptable just to use perf. Okay, there's a lot of.
As opposed to what?
It's called peel ply, and I'll cut some off. Just stay there, Dad. I'll come back with it. Now, peel ply is a Dacron or a coated Teflon coated. This is just, in the old days, this is just Dacron sailcloth. Okay, that's Dacron. And it doesn't bond, all right? And it'll leave a really nice surface finish. And if I were going to bond to this, I would probably put some of this down. Now there are two types of perf. One of them you're allegedly allowed to just bond straight to. I don't do that. This makes a nice surface finish. It smooths out some of the roughness, makes it easier to sand. But the reality is, you still need to sand it. If you're going once you go to the bond, you still need to sand it. But some people put this down as a matter of just
Principle.
yeah, just as part of their process. You don't need to do that. You need a good solid perf, and it makes a nice interior finish too. But if you're going to bond, there's certain times I'll use this, but I won't use it as just a matter of course.
Well, this equation going to be in all kinds of weather, right? There's no question about it. So,
Well,
is any part of this gonna deteriorate or revert back because of weather conditions? I mean, is it weather impervious after it sets up, or
pretty much.
so
Okay, well, the resins.
extreme heat, extreme cold, that kind of thing?
Well, extreme. I mean, we got to define what that means.
Yeah.
Okay,
I just mean what you would normally get flying across any part of any state in this country.
it's really not that big a deal. It's well within the mechanical properties of the resin systems. Okay, what we're talking about there is 200-ish degrees Fahrenheit down to negative 30, 40 degrees Fahrenheit. That's what we're talking about. We got
Does it get
50.
brittle and terrible cold like anything else? I mean,
Everything gets
Everything gets
more
brittle,
brittle at
yeah,
cold.
yeah.
But there's 50 years of
it's better than steel or aluminum.
everything has its own place. This is this is a good material for all of those things, but they all have their limitations. They all have things they're good at. They all have things that you probably shouldn't use them for.
But overall, this covers more bases than all the rest of them.
Yeah, we got 70 years worth of
Are the drones
data.
and stuff made out of this stuff?
Actually, yes.
The drones?
Actually, yeah. Predator.
Predator.
All that stuff, yeah, they're composite. They're made of this, large chunks of, well, the 777 fuselage. They've been making large chunks of the F-22 and F-35, and this isn't new. What I'm doing is not new. This part is, we're not breaking any new ground here. We're just using a technology that I understand
And
to
you've
make
used
parts.
this for years, haven't you?
Yeah, and not just me.
What kind of, you built drones in your time and all that before?
Yeah, we did.
Yeah,
We did.
so,
We
I
were
mean,
kind of at the leading edge of optionally manned back in the day. And this was 15 years ago.
That meant you could either fly them or remote them. Huh?
Well, flying in the national airspace is a real problem if unmanned. It's just not something anybody's really comfortable with, or at least they weren't at the time.
Even though, so the drones, even though a lot of them, maybe they would be in Afghanistan a couple of years ago, but they would be manned out of Texas or
That's
something.
a military thing, and they have different rules. But for civilian use, flying in the national airspace unmanned is they're still working out how to do that. That's what this whole drone thing was about. Okay, that's why they had all these quadcopter drones going out. That's why they had to finally go, all right, you guys have to have a license. You're starting to use a national airspace, and it's unregulated, and you're getting in the way of people who are trying to come in and fight fires and
Sure.
So people abused
I
the
can
privilege, and
understand.
they got
Well, as more get into it, you have to have some control over it. They were killing each other.
Yeah, that's right. So it ended up getting regulated. So we were in this 15 years ago, but we were doing stuff that could fly all the way across country.
From a seat,
Yeah.
or just from a chair and a table, huh? A computer.
Yep. Saw it happen.
Is it a weird? Maybe you have done it. It's a weird adjustment to flying without any feeling of the craft at all? You know what I mean? Like off a
Well,
screen?
it's just, it's like flying a simulator. It really is.
Oh,
There's a
yeah.
little lag time,
I mean,
and
the simulators move around, don't
yeah,
they?
not necessarily. Not
The
all of
early
them.
ones.
Not necessarily. They don't always. Most of them just sit there, and you just, it's just like playing a computer game. Honestly.
They fly them tremendously. I mean, over the last years in weird positions.
Yeah.
Drones, I mean,
It's come a long way, but the fundamentals of the aerodynamics and the structures are really pretty much the same. There's only so many ways you can build a plane, and there's only so many configurations of it that actually work, and it really comes down to the mission and getting your geometry to where it's optimized for the mission that you want, or as close to it as you can get within your constraints. So these are the things I understand how to make, and I know that I can make them into pretty much into the shape that I want easily. So this is the method I chose, and it's also a question of the environment. And I've gone into this before, but I chose a tooling method that we can pull off here, right? And a material that we can do at room temperature. You don't see an autoclave in here. We're not going to autoclave. There's a lot of kind of infrastructure that you need to do composites to, well, we'll just call it a space-rated composite. You're talking about autoclaves and clean rooms. This is a method of making it that doesn't require all of that, but still yields a part that's probably 90%, 90 to 95% as strong. So it's all balances. So yeah. Anyway, this is something we've been doing for, 30, 40 years. This method, it works great, especially for, private airplane like this. Anyway, we're deep into it now. I've got all of these. This is all the material prepped for these chunks. Okay. All of this material is prepped. This is for this. All of this, these are the foam cores for the horizontal stabilizers. And I'm just going to keep making parts until I run out of materials over here.
How many parts are in this airplane? Do you have any?
About 100.
How many?
About 100.
Only 100 parts? All these little...
50 molds, round numbers, 50 molds to make 100 parts. Some of them are like, this one gets turned 4 times, this gets turned twice per ship set, these get turned 1 time per ship set. A lot of these are, they're done in such, was designed in such a way that I can minimize to the extent possible the tooling, still get a high quality part out of it. So, yeah.
Did you charge this?
Anyway, that's that failed part because of that's a vacuum failure. Okay, that's what that looks like. These are going to go to the trash, but I still want to, we're early into the process of laying up, so I still want to look at failures, okay, and why. Because part of what we've been doing is just commissioning the entire process, right? The bagging, I've got 2 vacuum pumps over there. I'm going to take one. I found the one that works the best. We have a vacuum pump that was donated to us that's really good, but it also dims the lights. Yeah, I don't need that yet. So Katie's going to come in and work that out, because when we first started that, and again, it was 4 years ago, it was running perfect. So there's some stuff that needs a little bit of love. But yeah, we are starting the process of laminating everything. I'm going to clear these out, and we're doing 2 ship sets because Katie's going to have the other one. He wants it, so we're going to make a deal, and he's going to have the other airplane.
2 airplanes, yeah.
And I've prepped pretty much for 2 airplanes right here. I'll get all of these done. We'll QC them. We will fail what needs to be failed. We will trim what needs to be trimmed, and then we will just take another group of tools, put them out here, prep them, and do this again. we'll do these first, and then we'll just move upstairs and we'll just start making them bigger and bigger and bigger, you know. Fail small, fail early, fail cheap. You know what I'm saying? Get this shit out of the way where it's just 4 plies, right? As opposed to, you know, failing an entire wing. So.
What's this right screw? Oh, here we go. Yeah.
Okay. So that's the finished spar. It's pretty good. It's got a few little small cosmetic issues. It's pinholes. That's
It's
very, very normal, especially with just a vacuum bag. Actually, this is pretty impressive for just a vacuum bag, but it's heavy. I calculated that this should weigh 1.4 pounds. I am over by a solid pound. I'm also resin rich. Right.
You can tell that by.
I can tell that by just how much lensing of that resin I can see on the inside. This is one of the things that that prick perf will do. It seals off and it holds resin. You're not going to transfer a lot of resin out into the bleeder. I also just use 1 ply of bleeder. These are the things that you just have to experiment with on a part-by-part basis when you're doing laminations. I tend to run only 1 ply of bleeder because one thing is it's just easier when you're in this deep. Okay, when you're making something that looks like this, it's a minor miracle you can pull it off at all. All right, so I think this part ought to weigh 1.4 pounds. It is currently 2 pounds. 2.5 pounds, and it needs to go on diet. The flange is probably worth, it might be worth that 8 ounces, but we're still 25% overweight. So bottom line is I'm going to go back, I'm going to recalculate, I have to go back, do some math, make sure I have enough material in there, and if I can take out 2 plies of the uni, I'm going to try and do that, and that will probably bring me on weight. This feels a little porky.
So you got 2 of these available. You got another one, right? So you might actually, the other one, if you can get the other one down to 1.4 or whatever.
If I can get close to my weight, if I can get within 10%,
another one of the other.
Yeah, if I can get within 10% of my weight, then I'll make another one. I'll just reject this one.
This and see how much weight comes off.
Yeah, but I can see that it's also resin rich.
Yep.
Now that I got the process for this down, I think I can do better on the next one. I probably need to put a little more bleeder in there. But the reality is I think I just need to be a little bit more diligent about my resin usage. I got in a little trouble with this one yesterday. I had a bag failure. I had to rebag it. I'm just glad to actually have a part that's decent, but I think I'm going to reject this one on weight and remake it. Okay.